So this is going to be the Chapter 6 review at home. So starting off, find the measure of one interior angle in each regular polygon. So we're looking for an interior angle of a regular polygon. So if we look, an octagon has 8 sides, so my n is going to equal 8 in this one. 21 gone, my n is going to equal 21. So my equation to find the measure of one interior angle is going to be n minus 2 times 180 divided by n. So what I'm going to do is plug in my n. So this one, I'm going to get 8 minus 2 times 180 divided by 8. So we have 6 times 180, so 1080 divided by 8. So my one angle is 135 degrees. So now we're going to do our other one. So 21 minus 2 times 180 divided by 21. So 19 times 180 divided by 21 is about 162.9 degrees. So one interior angle would be 162.9 degrees. So find n, the number of sides given one exterior angle of a polygon. Well, if we have the exterior angle, we know if we were trying to find it, we would take 360 divided by n. But we're given the degrees this time. So we're going to take 360 divided by n, but we don't know what n is. We just know that if we would have done this, it would have given me an exterior angle of 40 degrees. Because 360 divided by n is the equation to find one exterior angle. So we're just going to solve. So let's multiply both sides by n. So 360 equals 40 times n, divide by 40. So my number of sides in this is going to be 9. So I'm going to do the same thing for my next one. 360 divided by n equals 30. So multiply both sides by n. So 360 equals 30 times n, divide by 30. So the number of sides in this one is going to be 12. Find the measure of the interior angle when you're giving the exterior angle. So I'm given these being the exterior angles. So first I need to find the number of sides that we're talking about. So we're going to do the same that we did last time. So 360 divided by n is 40 because I have the exterior angle. So if I solve it, it's going to be 360 divided by 40 equals n. So my number of sides is now 9. So I want to find the measure of one interior angle. So to find the measure of one interior angle then, I have to do the equation n minus 2 times 180 divided by n again, because we're trying to find one of those interior angles. So 9 minus 2 times 180 divided by 9. So 7 times 180 divided by 9. So one interior angle is 140 degrees. So we're going to do the same thing with the next one. So first I need to figure out how many sides I have. So 360 divided by n equals 13. So basically 360 divided by 13 equals n. So the number of sides is going to be, we're going to say it's 28. On the test it will be a more exact number instead of having to round any decimals. So we'll say it's 28. So I have the number of sides, but I want one interior angle. So we're going to do 28 minus 2 times 180. Divided by 28, so 26 times 180 divided by 28, so one interior angle is 167 degrees. Okay, so for this, my diagonals should be congruent, so if they're congruent, if these are congruent and these are congruent, that means we can set them equal to each other. So I'm going to have 2h equals h plus 5, and I'm going to solve, so subtract h. So h equals 5. If I wanted to find those lengths, I would plug this back in for h and figure out what those lengths are. Okay, it's the same thing. So my diagonals are congruent, so this is congruent to this, and these two are also congruent. So I'm going to do 5r minus 2 equals 4h, or 4r plus 4. So subtract 4r. So r minus 2 equals 4, add 2, so r equals 6. If I wanted the lengths, I would plug 6 in for r for all those lengths up there. So if this were a rhombus, so we're just going to make this a rhombus in this. That means all of my diagonals should be perpendicular. So the measure of angle 1 is 90 degrees. So I'm going to mark that on my picture. So that is 90. Okay, and then my diagonal should also be congruent in these when it comes to rhombuses. So the measure of angle 2, the measure of angle 3 should both be 58 degrees. So if the measure of angle 3 is 58 degrees, I'm going to take 90 plus 58, subtract it from 180. So 90 plus 58, and then we're going to subtract that from 180 to find the measure of angle 4, which is 32 degrees. Okay, if ln equals 4x minus 17 and mo is 2x plus 13, what are the lengths of the diagonals of the rectangle? So let's go ahead and label on my picture first. So ln, so this length, is 4x minus 17, and mo is 2x plus 13. So my diagonal should be congruent in a rectangle, so we're going to go ahead and set them equal to each other, because if they're congruent, we could set them equal to each other and solve. So we're going to subtract 2x and add 17 in the same round. So I'm going to get 2x equals 30 divided by 2, so x equals 15, but I wanted the lengths of the diagonal, so I need to plug it in. So if I plug it in for 2x plus 13, I'm going to get 2 times 15 plus 13, so 30 plus 13, so 43. And if they're congruent, that means they're the same, so that means both of those diagonals should be 43. Okay, I have a trapezoid. So trapezoid, we take half of our big length plus our smallest length and set it equal to our medium length. So I'm going to take half of 25 plus my small one, so 2x minus 1, and it should equal that middle one because it's like taking the average of it. So I'm going to simplify in here first. So I'm going to get 24 plus 2x equals 3x minus 6. I'm going to go up here. So I'm going to distribute that half sign. So now I'll have 12 plus x equals 3x minus 6. Let's go ahead and subtract x and add 6. So 18 equals 2x, divide by 2. So x equals 9. If I wanted to find the lengths, I would plug it back in. So this is a trapezoid when you have a mid-segment, when you're trying to solve for either the mid-segment of it or the outer lengths on it. A kite. So with this kite, we know that my non-vertex angles should be congruent. So these angles should be congruent. And we also know that my vertex angles have angle bisectors. So these are congruent to each other, and these are congruent to each other. So we're going to use those pieces of information to solve these. So first up, if I look, it's hard to see because I always mention you want to look to see if there's any smaller triangles in kites, because sometimes you can solve things in the smaller triangles. So if we're looking at this smaller triangle, all triangles should add to be 180 degrees. So technically, if I add 38 plus 17x plus 1 plus 3x plus 1, it should equal 180 degrees because it's that smaller triangle. So let's go ahead and solve for x. So I'm going to get 38 plus 1, so 40 plus 20x equals 180. Subtract 40. 20x equals 140. Divide by 2. So x equals 70. Let me double check on that. I miswrote that. That was supposed to be 20. So x then equals 7. That looks better. All right. So now let's plug it in to find those. So I'm going to plug x in for 3x plus 1. So 7 times 3 plus 1, so 21 plus 1, so 22. So that means this is 22 degrees right here. And then let's find the other one. So 17 times 7 plus 1, which is 120. So that one is 120 right here. And we said my non-vertex angles should be congruent. So now, to solve for y, I'm going to get 2y equals 120. I miswrote that 120 on there. 120. Ooh, that was really ugly. 120. All right. So now we're going to solve for that y, because those angles should be congruent, so we could set them equal to each other. So divide by 2. So y should equal 60. So now we have x and we have y. So my last one, let's go ahead and graph these points. So I have q being at -2, 0. So q. R being at 2, 3. S being at 6, 0. And T being at 2, -3. So we need to decide what shape this is. So it kind of looks like it could be a square or a rhombus. So see, we need to check to see the distance between the points to see if the side lengths are the same. So first we're going to use our distance formula. So our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So first I'm going to find the distance of, let's do, QT, and then we have RS. Oh, I'm going to move that down. And then ST and QR. So I need to find the distance between those points to figure out what those lengths are. So I'm going to plug it in to that formula. So I'm going to get the square root of, if I look at Q and T, I'm going to do 2 minus -2 squared plus -3 minus 0 squared. Sorry that it's hard to read these because of the color background. So 2 plus 2 squared plus -3 squared. So we're going to have the square root of 2 plus 2 is 4, 4 squared is 16, plus -3 squared is 9, so square root of 25. So QT is the square root of 25, which is 5 if you solve it down. So I'm going to quickly do the rest of these. So double check to make sure that you're plugging it in right for the next 3, because if you can't plug it in on this video, you're probably not going to be able to do it on the test. And there's a similar question to this on the test. So I'm going to run through it really quickly so that I'm not wasting a whole lot of time. But go ahead and try it on your own. Okay, so I should have gotten all of my side lengths to be the square root of 25, so 5, which means that all of them are congruent. So right now all of these are congruent, but now I need to check my slopes to see if we have any perpendicular angles, because if we have a right angle, that would constitute this as a square then. Okay, so we have to check to make sure that it's either a square or a rhombus at this point to see which one it is. So I'm going to erase all this and we're going to find the slopes of all of those sides. So my slope formula is y2 minus y1 over x2 minus x1, or you could just see how many you rise and how many you run to go from one point to the next. So if I was going from S to R, I rise 1, 2, 3, and I run to the left 1, 2, 3, 4. So left means -4. Okay, so my next one, let's go from T to S. So I rise 3, and I run to the right 4, so it's a positive 3 over 4. So my next one then, if I go from T to Q, I rise 3, I run to the left 4. If I'm going from Q to R, I rise 3, and I run to the right 4. So there's my slopes for all of them. So remember, parallel slopes are the same. So none of these ones that are across from each other are the same, which means that they're parallel to each other, but perpendicular is opposite reciprocal. So if I would have had 3/4, the opposite reciprocal would have been -4/3 for it to be a 90-degree angle. So because none of these are opposite reciprocals of each other, I don't have any right angles. So the answer to this is a rhombus, because there are no perpendicular slopes, but we have parallel slopes and congruent sides.